All right, welcome back. This is the second part to our network monitoring lesson. We're going to take a look at, now that we've seen the key performance indicators, one last important one is being able to monitor drop packets. As we mentioned though, there is a difference between dropped transmit packets and dropped receive packets, besides the fact that they're going in different directions. But it actually is where the actual drop packet is taking place is the indicator here. But things to note here, right? Packet data might need to be buffered before being passed to the next step in the delivery of your network process. The network packets are buffered. They're typically in queues throughout whole parts of the different layers of the environment, from the SOS through the VM kernel on out to the network. And reasons behind why would a packet get dropped, right? The buffers have basically filled up, right? The destination may not be ready to receive packets. The network may be too busy to send the packets, right? Queues are finite in size, as we all know. And the things like virtual NIC devices, they buffer packets when they cannot be handled immediately. And if queues in the vNIC fills, packets are buffered and by the virtual switch part. So when these queues fill up, no more packets can be received, which can cause additional arriving packets to be dropped. Essentially, there's a saturation, isn't there, right? That's the whole point of why these are being dropped, because the queues have now been saturated, and basically the destination, whether we're receiving or transmitting, isn't ready for the packets. And then if they're dropped, what do they need to do? They need to get resent, which is basically going to increase your latency. The thing is, we have to consider, where is the packet being dropped? Is it being dropped in the VM, or is it being dropped in the ESX server level, at the VM kernel level? Well, it also, again, depends on whether that it's a received drop packet or a transmitted drop packet. If it says here, it says, if a guest OS fails to retrieve packets quickly enough from the virtual NIC, receive packets are dropped and a network throughput issue might exist. I mean, think about it. When there is a received drop packet, actually one thing to just kind of consider here when it comes to the drop packets, you have to think of the entire stream here. And so when it's a received drop packet, it is likely that it's already made it through the VM kernel, through the virtual switch, and now it's being dropped at the end of that, which is the VM. And so if the VM is dropping the packets, it could be the VM isn't able to handle this incoming packet. It may require additional virtual CPU resources. So as it says here, check to see if this is happening. Is the VM experiencing high CPU utilization? That may be a reason behind why would you need to give the VM an additional virtual CPU so it can handle the additional incoming networking traffic. Or it could be you need to increase the efficiency with which the VM uses CPU resources. There could be a variety of different ways that the guest isn't using their CPUs efficiently. But a simple approach is to add a virtual CPU and see if that helps. However, a more likely case is maybe the guest actually isn't using the right driver for its networking. This happens actually more often than you'd be expected. And that is that if you find that the guest is actually dropping their networking packets, check what network driver are they using. Are they using the non-VMware Tools driver? That's not a good sign, right? You need to install VMware Tools in that VM immediately. If he's using the standard VMware Tools VMXNet driver, right? You got VMware Tools installed, but you didn't update it to VMXNet 3. This is the perfect time to consider making your change to VMXNet 3. Because at first you may be thinking, oh, VMXNet is great, but do I want to go and change out all of my VMs at this point? Well, nobody's going to want to do that. But if you're finding that a VM is experiencing dropped incoming packets, a more efficient and optimized driver for networking traffic is VMXNet 3. This is a justifiable time to go ahead and switch out that driver, see if it makes a difference. It may just be that the VM is experiencing such an onslaught of incoming networking traffic, it might need an additional networking driver, a networking adapter too. But, I would say one of the first things to do is take a look at what driver you're using. If it's not VMXNet 3, this is the time to add that adapter. Now, drop receive packets at physical NIC level. That's not as common, right? The host is receiving the incoming networking traffic, and the ESX server drops it before even giving it to the virtual machine. That could be a host that's just running too many VMs that are using the network. That's where vMotion might be able to help you out. Check to see what's going on with the CPU. If that host is CPU saturated already, it may not be accepting incoming traffic. It may not be able to run that many other VMs in the first place. So a vMotion opportunity here is probably something to consider. Now, drop transmit is not typically done by the VM. The drop transmit is usually as it's leaving the ESXi host, right? So receiving is typically a receive drop is usually at the VM level. Dropped transmit is a lot of times happening at the VM kernel adapter level. It could be that you have so many virtual machines on a virtual switch that are only using one physical uplink. That could cause potential drops there. Just a bottleneck of hitting the one physical adapter. Maybe time to, again, vMotion, find other hosts that have free resources so we could distribute the load a little bit better. Of course, having a NIC team on that virtual switch would also be beneficial too, so that we have a little bit more area to spread out the load. So adding uplink capacity, migrating VMs are probably some easy things to consider. Of course, the vMotion part is the free option. Adding capacity, uplink capacity, means having to go out and purchasing some hardware. It could be that there's just a bottleneck on your networking infrastructure on the physical network, so you have to verify that as well. And of course, reducing the networking traffic would help the issue of dropping packets. It's just that the network is being overloaded right now. And reducing the networking traffic might be solved by basically distributing the VMs across other ESX servers to reduce the load that way. So that's something to consider. And then what if we're having unexpected increases in data transfer rates, right? Each application is going to or can use the full bandwidth when no contention exists, but then when traffic flows contend for that shared network bandwidth, then the performance of the applications might be affected. High-speed Ethernet solutions, 10 gig of course, or 40 gigabit, would be able to support different traffic flows through a single physical link. But an important part of all this, of course, is using network out of control when you have a distributed switch. Remember, it's already enabled by default. Network out of control will ensure that all the VMs will be equalized right out of the box, making sure no one single VM can take over all the bandwidth, causing the other VMs to be starved from the network. No, network out of control will ensure balance across the entire virtual switch. So networking best practices. Recommendations: configuring your network, use VMXnet3 wherever possible. And then I don't know what the next point is. It says use VMXnet3, and if not possible, go with VMXNet or VMXnet2. I say no, wherever you can, go with VMXnet3. Use physical network adapters that support high-speed performance features, right? Most modern adapters do anyway. Team your network adapters for load balancing. Another one of those Captain Obvious rules here. To use separate virtual switches, each connected to separate physical NICs to avoid contention between VM kernel and VMs. Sure, that sounds like a great idea. Again, if you're consolidating because you have high-speed networks, then you're going to keep them separated using VLANs. But, for networks that support different types of traffic flow, network out control is great for allocating and control your bandwidth. It's already enabled by default, so you can tweak it even more so with network out control. And ensure sufficient CPU resources exist for workloads that have high network throughput, because of the overhead of having to deal with the actual networking overhead or the networking throughput. You'd want to make sure you are doing this on a system that is not CPU saturated. All right, our final monitoring lab, this one's interesting. This is using an open source utility called NetPerf, installed on your Linux 01 virtual machine and also on Linux 02. We're going to have two VMs working together here. What you're going to do at first is make sure that these two VMs, you need to make sure they're both on the same ESX server and they're on different virtual switches to start, because they're going to be on DVS Lab right now. So you're going to make sure that one's on DVS Lab and the other one is on that DVS SA data center, but on the same host. This forces the VMs to have to hit the physical network to communicate with each other. And our job is to be able to measure the actual bandwidth between the two VMs as the traffic goes out of one VM, out to the physical network, and then back in to the other virtual machines, right? So two different virtual switches monitoring the two different physical adapters. Now, this is a 10 gig quote-unquote network, right? If you notice, our VMs think they have 10 gig adapters. The ESX servers they're running on think they have 10 gig adapters. That's all kind of smoke and mirrors. We're running a nested environment. We don't nearly have any close to that bandwidth. So don't be surprised when the bandwidth, when you measure it, it's actually relatively low, probably even in the order of like 200 megabits. But that's okay. We're not here to say, oh, we're on a relatively slow network. We're basically here to just monitor it using the appropriate columns in your ESX top report. Then in the second case, you're going to simulate contention and congestion by enforcing traffic shaping on our distributed switches. basically shrinking it down to 10 megabits. So that one actually becomes quite predictable. Your bandwidth is going to go way down, lower than 10 megs, because you've capped it at 10. Then you're going to take those two VMs and put them back on the same distributed switch, on the same host, have them talk together all in the host, and see what the difference is. Hopefully, their overall throughput should go up, because now they don't have to use the overhead of hitting the physical network. They do all this in-house, right? All in the host. So here's our steps. You basically are going to ensure that the VMs are on the same host and they're on different virtual switches to start. And then you'll basically launch a server part to this tool, right? NetPerf, the way how this one works, you have to run a server called NetServer, and then you run a script that basically talks to the server with the whole set of network attributes that are defined in the script. So you need a client-server arrangement here. So one VM, you're going to get its IP address so that you can then run the script to talk to the server and start measuring the bandwidth. We'll then use task 4, traffic shaping, to simulate congestion, and then monitor the throughput using ESX top in that case. And then finally put the two virtual machines on the same virtual switch and see what kind of increased throughput you observe. So in our first case, you're basically watching VM to VM, but over the physical network. So you're going to be looking at the actual physical adapter, VMNIC2. And the same happens in the second case when you're adding traffic shaping. But in the third case, we're basically just looking at the bandwidth coming in and out of the VM, since we're not actually hitting the physical network in that last task. And we're basically here to compare, but I'll pretty much tell you, you'll probably have a little around maybe 200 megabit or a little less for the first round. Of course, the second round with the 10 meg traffic shaping setting, you're going to get no more than 10 megs out of that. You'll probably get about 9.5 megs. And then finally, in the last task, you'll probably get a bump up to a little over 200 megs. Even though having the two VMs on the same virtual switch on the same host, the increased throughput isn't that dramatic, because in a nested environment, networking actually just doesn't perform well anyway. So you'll see, though, it will be improved, though. So that's what we're here to look for. So we found in this lesson, we determined which network metrics to monitor, the metrics in ESX top, and to monitor key network performance metrics. And in this module, we saw the vSphere uses many performance features for modern network adapters, TSO and jumbo frames, for example. And the ESX top tool displays your physical and virtual networking data all in the same window. And the presence of drop packets is an indicator of networking problems, right? The things you don't want to have, right? You want your network drop packets to be zeros. Anything that's a non-zero is a problem. All right, so go ahead and complete the network optimization or network monitoring lab, and I'll see you in the next module.